For rational inequalities, I'm going to use the same two examples as in the previous lesson, where we graphed x squared minus 1 divided by x squared plus x minus 6, and we ended up with this picture. But I want to use this picture to figure out, well, where is the function less than 1? So the goal is to look at the y values of this graph, interpret what it means to be less than 1, and then the answer is going to be expressed in terms of the x values, since only x's appear within this equation. So let's examine the graph. Y equals 1 represents the horizontal asymptote. So that is this line here. To be less than 1 means if this is y is equal to 1, I want to find everything that is below this line. So if I look at this part of the graph, all of the y values are definitely above 1, so I don't want to include those. I want to find every part of the graph that is lower than y is equal to 1. Clearly that has to be everything on this portion of the graph. So I'm going to highlight that. I'm going to note that, all right, this part of the graph, all of the y values are definitely below y is equal to 1. So what we're going to do is say, okay, for all of those points, what are the x values? Well, the x values on this portion of the graph, they go all the way to this spot, up till I get to this location here. That is everything from -3 up to +2, and not including either of those places. So that is, okay, we have x equals -3 and x is equal to +2, the two vertical asymptotes. So that's part of my answer. Part of my answer is the interval from -3 to 2. But there's a little bit more. If we examine this portion of the graph, this is definitely above 1, but right when you get to here, so this is at x is equal to 5, that's where the graph is equal to 1. So I don't want to include 5, but I'm noticing that as I move in this direction, the graph now drops below y equals 1. It keeps getting closer to 1, but it can never equal 1 again. So I also want to include this portion of the graph as well as we head towards positive infinity. So that is going to be everything from 5 to infinity. I'll put a union just to say I'm taking both of those pieces, but it would be acceptable to write your answer as everything from -3 to 2, and also x is greater than 5. So again, what this is referring to is, here's y is equal to 1. That's this one here. I want every y value that's below it. That was this portion of the graph, and it was this portion of the graph. So I recorded my answer as just the x values. This portion of the graph went from -3 to 2, and this part of the graph goes from 5 to positive infinity. If we try this same idea in our second example, I want to solve this inequality. This time, I don't want it to be less than 1, but I want it to be greater than or equal to 1. I'm going to label that as, all right, here's y is equal to 1. It is, again, the horizontal asymptote. When is the graph above it? So scanning from left to right, okay, clearly I don't want any part of this. This is below y is equal to 1, but here's a portion of the graph that is bigger than or equal to 1. It's definitely greater than 1, and that happens as we go towards minus infinity. So this portion of the graph, I'm going to highlight it. All of these y values are definitely bigger than 1. So all the x values have to be from this location here towards minus infinity. Okay, this x value was x is equal to -3. So this is part of my answer. Everything from -infinity to -3. But if I continue to look at the graph, here's where the graph is also bigger than 1. And at this spot right here, it's actually equal to 1. and this is x is 1, all the way up until we get to x is equal to 4. This part of the graph goes from 1 to 4. I want to include 1, and I don't want to include 4. So again, you could write your answer as, well, x has to be less than -3, and then we're going from 1 up to 4. Both of these are completely acceptable, but this is the final answer to the question.